Hey there, classes, welcome back. If you check out the board behind me, I'm going to show you some of the handouts that we've seen this week. We've covered a lot of ground. We've got the scientists, the guest scientists coming on in on Thursday. They are going to talk to us about fossils. And if you look at the board right here, this is the second board. I'm kind of starting from the end of the lecture and moving back towards the beginning. And so I'll just cover some of the things that we've talked about this week, some of the things that should be in your notes. So let's check this out. First of all, we talked a little bit about the extinction of the dinosaurs. One of the cool things you might have seen is Oppenheimer this year. The movie that took home all the Oscars had at one point Luis Alvarez portrayed in the movie, a physicist over at UC Berkeley. He passed away back in the 1980s, 88 I believe. His son Walter Alvarez, still out there, an active scientist. And if you check out the Louis and Walter Alvarez science team, they did this really cool study where they found that there was a higher concentration of iridium. This should look like a review to you, hopefully. And remember, iridium, it's a metal on the periodic table, and the iridium concentration of this one layer in sedimentary rocks worldwide was a little bit higher than a concentration that you would suspect. And we think possibly this iridium layer, this dusting, if you will, of iridium, might have come from a large impact of an asteroid. Now, asteroid impact doesn't necessarily mean that was the only reason the dinosaurs went extinct. There are also, way up here in Siberia, they call them the Siberian traps, a large area of volcanic basalt that was all extruded roughly around the same time. Remember, basalt is igneous rock right here. This particular piece of basalt comes from the High Sierra. If you look at the basalt in combination with the climate change probably caused in a very short amount of time by the asteroid impact, it was probably, to use a boxing analogy, a 1-2 punch for the dinosaurs there. Certainly, we have found the asteroid impact crater, we think, down in the Chicxulub crater, they call it, down in the Gulf of Mexico. So when you put those things together, it wraps together with, at the beginning of this week, talking about producers, consumers, and the energy pyramid. Remember, we started the week, if you look back on our notes, if you look back on our online notes, talking about, my pen is not the best pen, an energy pyramid with the large base of the pyramid at the bottom being the producers. And we're not just talking about the producers in terms of biomass. Certainly if you were to weigh every single producer, biomass, the life weight, if you will, the amount of mass of the producers that are photosynthesizing here at the base of the energy pyramid, that has to be a very large base for the pyramid to support things like carnivores and top-level predators. And if you are doing something like wiping out the ability of photosynthesizers to take in sunlight, say a large asteroid impact that throws a lot of ejecta, throws a lot of dust into the high atmosphere, add that to your volcanic eruptions, that's something that could have pushed the dinosaurs over the edge towards extinction. So that's one of the things that we wanted to check out with our notes. So when Louis and Walter Alvarez were over at Berkeley checking out, I mentioned Oppenheimer because Louis Alvarez was portrayed in the movie. At one point, they have someone playing him, a very brief part. He was an amazing scientist. He was one of the first people that was over in Japan after the atomic bombs were dropped on both Hiroshima and Nagasaki. He was doing a study on the effects of the atomic bombs over there. His son also went into science, and their combination of looking at the isotopic ratios in the rocks said, hey, you know what? I think because there's no dinosaur fossils above this layer, remember the law of superposition, generally the layers on top tend to be younger than the layers on bottom, but there are dinosaur fossils below that layer. You probably have an asteroid contributing to the extinction of the dinosaurs. So that was the Louis and Walter Alvarez and the local UC Berkeley tie-in, which is awesome right there. Also, if we're looking at this right here with the timeline, I'm going to reach across here, and the students had this to do today. It's a little timeline assignment, and they're asked to add to it just a little bit. They're asked to put in, for example, when did the first flower evolve? Remember when angiosperms came along, they quickly kind of dominated the plant world. Seed plants were one of the things that was an adaptation to life on land. We've talked, for example, about conifers, cone-bearing trees, and the way they drop their seeds, the way seeds can last for a long time on land without drying out, and so they can survive the hard times until conditions are just right for them to sprout. We also wanted to put in, when did the first mammals evolved? And this is important because at the KT boundary, it used to be called the KT boundary, it's the Cretaceous Paleogene boundary now more often in your textbooks, but at the boundary where the dinosaurs died out, you've got the largest mammal at the time probably being, about the size of a squirrel or a rat, something about as big as a large rodent nowadays. And yet from that very humble beginning, we've got the diversification of all the mammal species that we see nowadays. We also were talking about, when we're talking about diversification in mammal species, the importance of protecting our environment. For example, earlier in the week, let me reach over here for one of the handouts, we had a little bit on climate change and the science behind global warming, global climate change. One of the things that sometimes you hear when people are bringing up climate change and the human impact on the environment, remember we're adding a lot of carbon dioxide. A big piece of coal is what I've showed before from my grandfather's backyard back in West Virginia. If you check out this piece of coal right here, by burning fossil fuels, by burning things that add CO2 to our atmosphere, we're warming the biosphere. And you may have heard the argument, well, the climate has always changed. And it is certainly true. The climate does change regularly on our planet. We've gone everything from snowball or perhaps slush ball Earth, but a very cold, cold planet, to times when the entire planet was tropical. For example, tropical evidence found in places like present-day Antarctica that really never got that cold as we see today. That is true. The climate does continually change over the long history of our planet. The thing that we are trying to guard against is changes that happen more rapidly than life can adapt to it. Certainly, as the climate changes over the long history of the planet, we have life slowly adapting to those changes. When changes happen more rapidly than life can adapt, that's when you get mass extinctions. That's what we're trying to guard against right now, is going into the 6th mass extinction. We have had 5 large mass extinctions, the most famous of which being probably the one 65 million years ago that wiped out the dinosaurs, but there have been other extinctions as well. One of them even wiped out 90% of the species on the planet. And by burning the fossil fuels and throwing the carbon dioxide into our atmosphere so quickly, we are quickly making it impossible for a lot of life to adapt to those changes. At the beginning of the class today, the first part at the very, very top up there has to do with advisory, checking out a little bit of the movie Wonder and Advisory. We had a little bit more time for that today. But getting back to the dinosaurs right here, it's not as if all of the dinosaurs went completely extinct. You have birds that are evolved from the dinosaurs filling an ecological niche. And when you look at a modern bird, you're looking at the remnants, the remains, if you will, or the modern descendants is probably a better way of putting it, of modern dinosaurs. When we're checking out dinosaurs in particular, remember we divide the long geological history of the Earth into eons first. Eons go on and on. Eons are the longest period. They're like staff meetings. They seem to drag on forever. But we do divide those into then eras, and then eras are further subdivided into periods. And one of the things I'm asking the students to do is to make sure they know the 3 periods into which, into which we divide the Mesozoic era. And when we divide it into those 3 periods, we can put onto our timeline when certain events happened. For example, the breakup of Pangea, the first flowering plants, and one of the little things that I'm just going to end up on here, which goes back to our unit that we did on Hawaii, and I just wanted to make it clear for the students. I asked the students to add to their sheet, when was the first Hawaiian island? Just to be more specific on that, and so I have the answer up here on the board. It says 80 million years ago. If you look at the modern Hawaiian islands, the 3 islands, I won't draw them on the board, but as you might remember from last week, as they generally trend up to the northwest, Kauai is the oldest Hawaiian island. That's above the surface right now for the most part. You've got it about 5 million years old. As you get further and further and further from the hot spot, you go from the large islands to these little atolls. You remember we talked about Midway Atoll. We talked about the plastic pollution on Midway Atoll, what we're doing to the producers in our ocean by adding so much plastic garbage, polymer garbage out to our oceans. We talked a little bit about the changes in the environment out there. By the time you get to Midway, you're talking over 20 million years old. If you follow those seamounts all the way up to where they're subducting by the Aleutian Islands, finally you get to an island, a little seamount, not above the surface of the water at all. That's around 80 million years old. That likely was the very first Hawaiian island, if you will, that popped above the surface of the ocean. So the first Hawaiian island appeared before the last dinosaur died out. It's kind of cool to think about. So with that, just make sure you have your notes updated. Make sure you have your timeline in your notes. And we're going to continue to talk about with our guest scientists tomorrow the different types of fossils, how we know what we know about evolution, and the likely future for life on this planet. With that, I'll let you go. Have yourself an awesome day. Bye-bye.